Hey everyone, welcome back to Press Start, where we take it from concept to console and we interview people from all around the game industry, the game dev industry, to give you an insight on what it's like behind the scenes of all the games you love. Today we have Faraz Khan. Nice to have you here. Could you tell us a little bit about what you do?
So I'm a developer. I've been doing game development since 2014. That's basically what I do.
Mm-hmm.
Yeah.
Okay, but what first got you into game development? Like, what made you realize it could be a real career from the start?
So I used to play a lot of games when I was young. I was like, why not? Let's just develop them. I was very into art, so I started doing a lot of 3D modeling. And then I realized, how will I actually animate these 3D models? And then I discovered coding. I read into C++, Java at that time, because Minecraft was made on Java. So I was like, why not? I thought I'll be someone like Notch, making my own game.
Yeah.
So I just started developing. I learned a lot. I got few of my friends interested in game dev, and actually that's how it starts for most of the startup companies in game dev.
Did you start with any Minecraft mods by chance early on?
No, actually I didn't start with any mods. I was a big fan of TF2.
That makes sense. So the source engine, I assume?
Yeah, so it was already a mod of Counter-Strike. So I was like, I create something better than TF2, like better classes, better character. I was very ambitious, very naive, but then that led me to discover a lot about game development.
Okay.
Yeah.
Now, something you'll hear later on throughout this interview as well is a few trivia questions. So to start off with, something simple. In game engines, what does the acronym ECS stand for?
ECS, Entity Component System.
There we go. Can you explain what that is?
Okay. So basically, traditional programming, you have object-oriented programming, so classes, right? Actually, before that, if I go, it's C. So that's procedural programming, where you have functions and they do a set of tasks. So with object-oriented programming, the design became extensible. They encapsulated problems well, and you're able to expand on these problems better because of this design. However, this leads to slow performance because each of these objects are in different memory locations. So if you were to run them, like for example, you load enemies, you need to go inside the memory block, find the enemy where exactly it is, and then show it. So that takes compute power. So basically, ECS is data-oriented programming, where they have everything aligned in one data in the memory. So you can access the next enemy to spawn very quickly. So that's why ECS is good with when you're spawning, I don't know, like 10,000 enemies of the same type. And ECS is also because of this performance, it's very good for networking because the problem you have in networking is latency. Yeah.
So everything's processed on its own instead of the overwhelming load.
Yeah. So it divided into entity, components, and system.
That makes sense.
Yeah.
Okay. Now, for students listening, what does someone like you do, a senior developer? What exactly do you do day to day with your company and all? What exactly happens?
Okay, so I mean, there's a set of tasks everyone gets. You have to do the set of tasks. I can't go more in detail of what I do, but like, for example, a set of tasks could be, okay, you're designing some meta in a game, right, related to player interactions with, okay, let me give you an example of my game. So I worked on a lot of hyper-casual games back then. So you do a lot of game development work, like how would this object move? What would the physics be? And how would people interact with them, right? As a game developer, that's what you do. But if you are a game developer. But in game industry, I mean, there's a lot of fields, right? You can actually major in engineering and just do engine level coding, which is nothing related to any of this. You go in serialization, you go in something else. So from game development perspective, from my day-to-day work, I just basically make object move. Yeah, to sum it up, yeah.
So whatever's needed for the greater task is what you're given.
Yeah.
Okay, that makes sense. Now, when it comes to what you're given throughout all these tasks, how do you balance creativity and technical limitations when you manage a large project like this?
Yeah, that's a good question. Actually, there's always, when you're programming versus, like, you always think about design and performance, and it's always that trade-off. And it's the same thing goes for creativity and technical, right? When the trade-off happens, you really have to be more creative to find better solution around the technical limitation, right? Actually, the current company I'm in, like, we're doing incredible work from technical standpoint. I cannot say what we're exactly doing until it's released. But there was a recent trailer from Monfish on this. And I mean, I don't know if you checked it out, but what they're doing is, like, they're moving worlds. And it's insane, the amount of, because you're moving world while it's real time. Right?
Okay, so the whole world itself.
Yes, the whole world itself.
God, okay.
Yeah, so, but there's a lot of, like, behind the scenes, you know, for performance.
Of course,
yes.
yeah.
But, like, there's always this trade-off, and when this happens, you have to be creative enough to turn that technical limitation into something which is actually playful or fun.
Okay.
Yeah.
Well, on the topic of 3D rendering and these behemoths of rendering, a simpler question, a trivia question once again. What does the term frustum culling, if I'm pronouncing this correctly, refer to in 3D rendering?
So basically, you have a camera, right? You look at I'm looking at you right now. I don't know what's behind me. So in a computer, to render things fast, gaming is all about real-time rendering, unlike Blender.
Yeah.
So performance is the key. So they have a lot of features around this to make it faster. So frustum culling is basically, it does not render objects behind the frustum of the camera. So less compute time.
Okay.
Basically, yeah.
That makes sense. Now, what game engine or tech stack do you prefer and why?
What game engine? Okay. Now this is very subjective. This depends on the game.
Yeah.
I have more experience in Unity recently, but I'm doing a lot of Unreal Engine games. It really depends. Unreal Engine is very good for Windows. They're very good for PCs. If your game is AAA level or AA level, you definitely need Unreal Engine because they have a lot of plugins, unlike Unity. But Unity is very good for indie development. So if your game is not high demanding on graphics and you just want to appeal to the audience based on the gameplay, yeah, you can go with any of them.
So would you say that for people starting off trying to make a small and simple, almost like a testing game, Unity might be a good choice?
Yeah, for sure.
Okay. What do you think about a lot of people starting to use the engine Godot?
Godot, okay. Not a big fan. I mean, you can use Godot, but in the long run, you need to actually improve your skills on something that will end up or that will give you the opportunity to grow even further. Godot has limitations in that, like, it's just like a sandbox, in my opinion. I think a lot of people will disagree. But personally, Unity and Unreal Engine are very good engines to know. But all of these engines, they have the same concept. So if you know one, you can know the other. It's just there are different tools, different concepts, different naming. Unity has game objects, Unreal has actors, but pretty much the same thing.
Okay.
Yeah.
Well, on a similar note to these almost underused or underutilized tools or devices, what's one underrated skill or language you think people should look into a lot more in this sort of field?
C++. You need to look into C++.
Why so?
Actually, C++ teaches a lot about memory management. In game, you don't need that, but depends what game you're making. A lot of the times, these engines have already they did the heavy work for you. But there are times where if you have a custom logic and your game really requires you to redo whatever they did, in that sense, you need to have that knowledge on how you can actually, go into that memory level, in packets level, and create a networking solution for your game. An example for this, I mean, there are so many games. Like if you see Overwatch, they are the ones who came up with dots, right? With the concept because of their performance. So actually, going back to your question, technical limitations versus creativity, there's always this bar that people are trying to push everyone is trying to push in the gaming industry. And when they push that bar, that leads to more creative work in terms of different types of games. At least, I don't know if you played that game where everything is like illusions.
Superliminal.
Yes.
Yeah.
Have you played? Yeah. So it's, I mean, it's insane. Like, yeah. I mean, there's little tricks and trips and shader programming, but it looks amazing.
Yeah. I mean, that is pushing technical limitations in a very creative way.
Yeah.
Okay. So on a similar note to what we referred to earlier with the 3D rendering and physics as a whole, in physics simulation, I hope you're going to get this, what does rigid body refer to?
Okay. So rigid body basically means basically an object can move and behave and simulate physics, and this object needs to be rigid, and that's what and the physics will work for it, right? If an object is like gooey or slimy, you don't use a rigid body for that. So just to make a static mesh move or behave like real world physics, you apply a rigid body, or you make the object a rigid body to apply physics.
So like a ball that would like squish once it falls isn't rigid body, but one rolling down a hill is. Okay, that makes sense.
You get it, yeah.
So when it comes to, how long have you been in the gaming industry, first of all?
About a decade.
Okay.
Yeah.
Well, I'm assuming you might have some insight on this question. What do you look for when reviewing a junior developer's portfolio or code sample?
Oh yeah, what project he worked on. That's it.
That's it?
That's it. Like if you're telling me you have a degree, it doesn't mean anything. But if you're telling me you worked on this and this game and this was your project and you can show me, then I know you did.
So it's all about the level of things they can show and like essentially how do I say this? How big the names are, if you will, or?
So it is a creative field. So you need to show your work. So if you have no work, then I know from that what's your level, right? And in game dev or in any creative field, you need to keep doing in order to improve.
Okay,
yeah,
that makes sense. Now we have a final question. Before that, one last trivia question, and this is way less on the 3D rendering and modeling side and a lot more on the coding side. In Git, what command permanently saves your staged changes to the repository's history?
To the repository's history. So you need to do get add dot, get commit, and then get push.
Okay, and what exactly does that do for people who might not know what that is?
So get is basically a collaborative tool, right? If I'm coding, you're coding, we need to sync up with our work. And get is basically you work offline, I work offline. We do our changes and then we push it to one branch. And we do that by first adding the changes, that's the get add. The dot refers to, in this case you add everything or you can select. In get they also call it staging. And then you commit is basically the things you added, what did you do with it, just as a history record. And then push is actually pushing from your local branch to the remote branch, which we are syncing on. But that's not like all the time. It's not that simple. So like there's a lot of merge conflicts. So we have to sync not on get but with each other. That okay, I'm working on this, you're working on that. Because in Unreal Engine or in Unity, you deal with a lot of binary files because it's engine level, and you cannot merge a binary file. You can merge a code because it's all text, right? So if you had something in a new line, I can merge that line. But a binary is just like set of like random characters.
Okay.
So for that we have to be in sync.
Okay. Now on a final note, well, a double question, but a simple question. What new technologies or trends are you most excited for in game development? And on top of that, is there anything you'd like to promote before we're done?
In game development, it's always nice to see what's happening in Gamescom. Like I'd really like what they showcase there. In particular, I'm waiting for GTA like everyone else. Stuff I like to promote. I can talk a lot about my game, but I would like to promote it once I know that it's good enough to promote. So as of now, nothing. Yeah.
Okay. Well, anything on your end, like yourself, or?
To add, I mean, I would just say like people who are actually learning game development, I mean, just do it. You know, just try to make like the whatever you have in your head into reality, and you will figure things along on the way. You know. That's
Okay.
it, yeah.
Well, thank you so much. That's been Faraz Khan, and this has been Press Start, where we take it from concept to console, and just remember to never stop learning.